welcome back to the Hangover, everybody. We're talking
Hangover,
telescopes, which means in the Hangover we will get away from telescopes.
Yeah, I'm sure we'll rant about something.
Oh, without a doubt.
Or another. Jack's pouring a second drink. Is it the same drink, Jack?
Is it the lingonberry?
Is it
with
a different drink?
Whatever it is that you had with the lingonberry?
Also, Jack, I was expecting you to explain what a lingonberry was.
A lingonberry was grown first by
Abraham Lincoln.
Abraham Lincoln, who killed vampires with an axe.
That was a fun movie.
That was fun.
Anyway, we're already off topic. Hey, Mom. Hey.
I think when we brought up horses, your mom...
She tuned in immediately.
Oh.
She was like, I'm on this.
She was like 38 miles per hour, which
35 miles per hour.
Well,
no, it was 38. It was 38.
Which I was like, well, that's very specific.
Mm-hmm.
That's a very specific number. And it goes sometimes faster, sometimes slower. Racehorses go faster. It's just like, oh, I'm going to contribute to this podcast.
My mom always contributes. She contributes
she does.
Good stuff.
She does.
Anyway.
All right, so we're talking telescopes today, and
do you want to recap what was said in the main episode?
Well, what did we say in the main episode? What we said was telescopes were invented. They have been around for centuries. Invented by Lippershey, who was given credit for.
Telescopes were invented. They were improved upon. We see shit with them. We made discoveries with them, and they're cool.
What she said.
So that's basically.
And you should be looking through telescopes. Yep.
You
in the mirror.
We're talking
in the
to
mirror.
you.
In the camera.
You right there. You you. Go look through a telescope.
Hey. You need to start paying attention to this fucking podcast.
You can't point at yourself. You got to point at the camera because the camera.
You over there, to my right.
But now your hand's in front of your face, so
nobody needs to see me. Nobody needs to see me. All right.
Anyway,
actually, let's talk about some of the discoveries.
Okay. Yes. Yeah. We didn't actually get into like what Hubble sees and stuff like that. I pulled it back, and then we never got there.
Yeah. I do want to talk about Tombaugh because because it's an anniversary. Not so much the discovery of Pluto itself, which was in February of 1930, but another anniversary related to Pluto. So, does anyone know how he came up with the idea?
What do you mean, Galileo or Lippershey?
Lippershey. If it's Lippershey, I can tell you. I can tell you.
That one.
All right. So if it's Lippershey, however you want to pronounce it, he was in his optical shop, and there were kids that would come in and they would play with glasses and the magnification of it, and he was able to make the leap from there to do the spyglass.
Children are our future.
Yeah. So so that's how. Or I should say that is the common belief that how he came up with the idea.
Okay. The first guy. Okay, yeah.
The first guy. So Clyde Tombaugh discovered Pluto at the Lowell Observatory up in Flagstaff, Arizona, where we have been, and we went, and the lady giving the tour. Apparently, they are fanatical about Pluto.
Yeah, you don't talk about Pluto not being a planet. Oh boy.
Yeah. But anyway, we are at the 15th anniversary of the International Astronomical Union, the IAU, their decision to declassify Pluto as a classical planet.
And reclassify it
as a dwarf planet.
Notice how neither of us said it was demoted, because it wasn't a demotion. It's a reclassification based on new and better information about an object we couldn't see very well.
Yeah, and the story of Pluto really is the story of science. Just forget how you feel about things. Because in the end, how you feel about something really doesn't matter at all.
In science.
And so when we discovered Pluto in 1930, again, using the Lowell Observatory telescope, we didn't really know of a lot of things out, and it went around the sun.
They could see Pluto, and they could tell that it orbited the sun.
That's and so it was classified as a planet. Well, we've learned a lot since 1930. That was 90 years ago.
Wow.
And we've learned a lot about our solar system and what things are in our solar system. Mm-hmm. And it got to a point where we just needed to really come up with a definition of a planet. Because prior to 2006, there was no definition of a planet. Mm-hmm. We didn't have a definition for a planet. And so they came up with one in 2006, and you might not like it, but at the end of the day, it doesn't matter.
It is what it is.
It is what it is.
And I mean, there is debate within, the scientific community versus astronomers versus planetary scientists and what constitutes what. But at the end of the day, it really matters in terms of just a scientist's classification of things, and it's just a way to refine things to show a new or a refined understanding of something. But really, at the end of the day, it doesn't matter as long as we're studying it and we're learning new things, and we're and we've been able to learn more about Pluto because of the advances of telescopes and our technology of how we can view things in space. Mm-hmm. I mean, Pluto's far away. Pluto is what, 11?
Well, hold on. No. I gotta think about this.
I can't remember how far away Pluto is.
2, 3.
2 billion?
It's 4 billion miles away from. It's 4 billion miles away from the sun.
Far away. It's smaller than. Is it smaller than? It's
smaller than our moon.
Smaller than the moon.
If you could put Pluto on the surface of the Earth, it would go from the East Coast.
Yes, 3,000 miles across, right?
To the Mississippi River. Not even.
Oh, not even.
Not even. It goes halfway across the U.S.
That's a small object to be able to see.
I know, right?
And it's in our own solar system. Because, I mean, it's small, so it's not like it has a lot of surface area to reflect a lot of light. It's not getting a lot of sunlight because it's so far away from the sun, and imagine, and what we've learned about Pluto is that it does have a lot of ices. It's an icy body out there, luckily, so it does, have a higher reflectivity.
Right.
Whereas if it was made of something darker, a darker material, I mean, it would be even harder to see. I'm sorry, I interrupted your point. You can continue going. I don't know. This is the Hangover. This is what happens. Okay, go on.
Well, no, all I was going to say was that, I wanted to talk about Pluto just because it's the 15th anniversary of the IAU.
Yeah.
Reclassifying it. And based on data that we have discovered through telescopes. Telescopes are our only way in which that we can see far into the universe.
Yeah, we can't.
We can't go there.
Our eyes aren't that great.
Yes, there are only a few examples where we have actually landed on something and measured that object there, and that would be. I don't even know if we took actual measurements of Venus, but we will say Venus,
and Mars,
the Moon, and Mars. Those are the only 3 places where we've actually landed and actually have done some physical measurements of things.
It's in fact, there's only one other place we could actually land. Well, no, other than other planets, is Mercury. Yeah, can't land on Jupiter.
No, and so. The only way in which we can explore these objects is through the light that they emit, i.e. stars.
Or reflect.
Nebulae, or reflect. So planets, moons, things like that. And Oh, okay, I thought
I'm sorry, I thought you were ending, and then I started.
No, go ahead. Go ahead.
My mom just asked, are there other objects like Pluto out there named or not? And yes,
yes,
and that is what led to Pluto's reclassification. Is because with telescopes in 1930, Clyde Tombaugh, all he saw was like this one small object out there that they confirmed was orbiting the sun. So they're like, aha, there's another planet. There's the 9th planet out there. But then as technology got better, astronomers began to find more and more objects very similar to Pluto in size and composition hanging out in the same neighborhood. One of those,
Eris,
they thought
Sedna.
Eris, which they thought was bigger than Pluto. Turns out
It's
it's not.
Smaller.
But they thought it was bigger than Pluto. And they're like, wait a minute. We're finding all these other objects that are very similar to Pluto hanging out in the same area. Are these planets? But they're, because they're in the same neighborhood, that's when they were kind of like, you know what? Maybe we should refine our definition of a planet in order to better categorize these new objects that they're finding. And so Pluto, it turns out, it's really part of a greater neighborhood of like comets, essentially. And some of these comets have been able to get big enough where they're spherical. Gravity shapes them into a sphere, which is the least energetic state for an object.
Well done.
I just like showing that off that I know that. But anyway, and so you have Eris, Sedna. There's there's Maki. There's like Quorer.
Yeah,
I can't say it.
I can't say that
and then so New Horizons is headed out or already went by some other object out there. And so yeah, our solar system is filled with shit, basically.
Yeah.
But most of the stuff our solar system is filled with is like small and really hard to observe unless you have something an instrument that is high powered enough, that's big enough or close enough to really observe.
But you still need
objects.
light, so you need a telescope. A camera is a telescope.
A camera's a telescope.
A camera that can zoom.
It
is
takes
a telescope.
in light. And then it turns that light into an image that your brain can comprehend.
Yeah. Your eyes are telescopes. But, Mike Brown, who discovered the object that led to
Eris.
the...
It was Eris? Yeah, which is
Eris.
Eris, which is the goddess of discord, because she threw everything into disarray.
So he discovered the object that led to the reclassification of Pluto. Please follow him on Twitter.
He's fun.
He is
Pluto Killer.
Pluto Killer. At Pluto Killer. And his license plate on his car is Pluto Killer.
I would just take that and run with it.
But ironically, so everybody was all in an uproar about him removing Planet 9. But he and some colleagues were looking at all these other different objects in our solar system using telescopes, and they found that their orbits could only be the way that they are is if there is a very large planet in a very distant part of our solar system that has yet to be discovered, and it's called Planet 9. And so he might actually bring Planet 9 back.
Yeah. Yeah. Here's and this is just I'm going to take like just a slight side path, and then we'll get off of Pluto and the whole Pluto thing, because I know we've talked about it before ad nauseum. But, and this comes from the article I was sent, which, since I read it recently, it's fresh in my mind. But we as a species, we like to God damn it! I was so confident in my head that I was going to say it. We like to we like to humanize everything. We like to give everything human traits and characteristics and personalities. I mean, the dogs. I talk to them like they're children when they got the mental capabilities of 2-year-olds. But anyway,
she does. I do too.
I mean, so it's like for a lot of people, they grew up with Pluto as a planet. It's like. And to hear it, and because in the media it was like a demotion for Pluto, so then everybody was like, "Oh no, Pluto's demoted. What did it do to deserve that?"
Didn't get big enough. Didn't clear its orbit. It did not clear its orbit.
So we attach these human emotions
feelings and emotions, yes,
to these things, and that's what kind of drives that sort of real kind of, at least the public debate on Pluto being a planet or otherwise. Whereas like a scientific debate is really more of like the like those fundamental characteristics of, you know, it's really about the gravity and its gravitational influence. That's what the debate is between like astronomers and planetary scientists is like
and that
the gravity factor. But
that debate continues, and it has real value because it advances our knowledge of things, our understanding of things.
But whining over if it's a planet or not.
But at the end of the day, Pluto doesn't give a shit what you think, and it doesn't care what your kids think about.
Because it doesn't have a brain, because it's just an icy fucking
ball. It's a comet.
It's a ball of ice orbiting the sun.
It's a comet. It's basically a comet.
Yeah, it travels like other comets. I mean, it's in orbit around the sun, and it's tilted about.
It's
20.
No, it's 20 something, right?
Yeah.
You know what? I might be thinking of the Earth.
I might be thinking of the moon, actually.
Anyway, it is definitely its tilt. Was one of the first things that
it's always been weird. It's always had things about it where people have like been like, you know, Pluto's weird. Pluto doesn't quite like its orbit being tilted off the plane of the solar system. That indicates it didn't form at the same time that the solar system formed and the other planets formed. So that right there is a little bit of a red flag that something's a little different with it. But you know, in order to understand these things, to discover these things, to learn about these things, you know, we need telescopes. We need that technology sent out there. Just like with Uranus and Neptune. Uranus and Neptune are planets, full-fledged planets, as according to the definition of a planet. They are these gas giants, but also ice giants that are known as. And we really don't know a whole lot about them. Like, Uranus doesn't have a lot of storm activity. We don't know why it's tilted
we
on
need
its
a spacecraft to go there.
Neptune's got like a dark spot that goes and comes back.
Which was discovered, that was discovered by Voyager.
And our only spacecraft that's ever flown by these planets is Voyager 2. That's it. We've had one spacecraft in the whole history of our human spaceflight, or, you know, robotic spaceflight, that has ever flown by these planets. So it's either Voyager 2 or Hubble Space Telescope, or amateur other telescopes.
Well, no, it's others.
I mean,
Mauna Kea down at
but Hubble's
Chile.
Gonna get like a better
Hubble,
view.
definitely.
I mean, that's what I'm saying. Like,
definitely, Hubble shows that the Great Dark Spot went away.
Yeah, I'm saying because it's you know.
Right.
But you know, it's like we have to rely on, you know, our ground base or, you know, orbiting telescopes to study these planets, because we've only had the one spacecraft fly by it. And really, if you want to study something, you know, your best way is to get an up-close view. And the best way to get an up-close view is to send a spacecraft which has imaging technologies, which is basically
until we can do that. Yes, it's like a telescope. We have telescopes that can show us things. What is one of your favorite telescope discoveries? I'm trying to channel Brandon in that question because he asked shit like that.
Does that mean you're not going to answer the question?
No, I'll answer the question. I have a definite thing.
Oh gosh.
I have two things actually.
What is my favorite discovery?
All right. Well, while you think about it, I will tell you that my two.
Oh.
Dark energy completely changed everything about the universe, and things that we don't is something we completely don't understand.
Yeah.
The second thing is in the mid 1980s, I was working at the Melton Observatory in Columbia, South Carolina.
I was born.
Yes. The Liz and Mike's World Telescope Tour.
I like this idea.
Let's do it.
I like this
idea.
Do
it. Okay, so I was working in the Melton Observatory, and one of the first exoplanets were discovered, and there were, and it had to do with a pulsar, and the astronomers were in the UK.
Okay.
And they had a paper, and I wrote to them. They sent me their paper, and so the plan was for us to do.
Oh, I don't know if you heard that. That was a dog bark.
Oh shit! I didn't hear it.
Well, I heard it.
Are they our dogs?
Yeah,
Did our dogs?
Jack just did it. He just ran downstairs and went. Oof.
Well, I saw Leia. All right. But they sent me a paper about their discovery of it, and the plan was for us to try to replicate.
Mm-hmm.
We quickly found out we couldn't. Yeah. So that the exoplanets and the discovery of exoplanets is another thing that is another discovery with telescopes that I just think is the greatest thing, because we're not alone.
Yeah.
It was the first time that we realized that we were not alone.
Yeah.
And there are other planets that are out there. Yeah. And the first planets that we discovered went around a pulsar, which really fucking blew our minds.
Yeah, that's kind of crazy.
That's crazy.
That's not a hospitable place.
Because what was crazy about it was that the supernova that created a pulsar should have destroyed those planets, and it did. These are second generation planets. These planets formed out of the debris from the supernova explosion, and there were 3 of them.
So cool!
It really is cool.
I don't think I knew about this, and that is so second generation planets.
And that was the first. Those were the first planets that we discovered. Was not around a star like our sun. Was around a pulsar, which is a dead star. And then our technology advanced to the point where we could find planets going around stars like our sun, but they turned out that they were what we call hot Jupiters. Wow. They're the size of Jupiter, but they're very close to the star. And we're only really getting into where we can find Earth-like planets. And if you can find Earth-like planets, now there's a difference between, when astronomers say Earth-like planets, they're talking about the size and the mass and things like that. Yeah. And maybe the distance. They're not saying this is, hey, there are people living on this planet. However, some of these planets, though, they might be in what we call the habitable zone, which is the zone around that star where you can have liquid water on a planet.
Which we know is a nice thing to have.
It's a nice thing to have. And there might be life. Where there's water, there's life. Possibly.
I hope that somewhere in the universe, which is an unimaginably, uncomprehendibly big place, that there are little green men and women, or theys and thems, what have yous.
I gotta take a drink, everybody. I heard dog bark.
Yeah, that was definitely dog bark. I don't know what's going on outside, but they're excited for something. Little green thems, somewhere in the universe, just to kind of validate just our imaginations of little green things out there in the universe.
What is it you asked me? Was it last night? Like, what's the percentage of, is there life in the, and I said 100%.
And then I said, do you think puppets could be a real species?
Oh, yes. That was almost the title of this podcast.
We didn't have a concept yet for the show, so then it was almost like, what if puppets were a real species?
Yeah. Your mom asked not atmosphere. Well, our technology, the best that we can, we can't really sniff out that atmosphere.
James Webb, though.
James Webb will be able to.
James Webb is the next step in exoplanet science, basically.
Right. And so all we can say is that, all right, you have this planet that goes around the star. It is at a certain distance where it's massive enough to actually hold on to an atmosphere. And that type of thing. That's at this point in the game, that's all we can say. James Webb, however, will be able to actually say, yes, there is an atmosphere around that planet.
And then it'll be able to say, like, it has
methane
or
which
nitrogen,
is very important.
Oxygen.
Methane and oxygen are really and truly two
farts.
things that we're really looking for. Methane farts, yes. Because they could, if you have a sustained methane atmosphere, sustained oxygen atmosphere, those are indication of the possibility, I want to underline possibility. Of life. And whether it's microbial,
some organic,
or little
like,
green
biological things.
There are also geological processes that can create methane in an atmosphere. There is a thing, I think it's called a methane anomaly or something like that. It is in Mars's atmosphere. There is a location where the methane gets replaced every year. Replenished, that is the word. Replenished every year at a certain location, and it's got astronomers excited. The problem is there's also geological explanations for this. Methane, it goes up into the atmosphere, ultraviolet light hits it, and it gets broken apart really easily. And so when it gets replenished,
that's a sign of, like, hey,
people get excited. I get
happening
excited
here. That's interesting.
Rock poops.
Rocks poop. Yeah, it's rock farts.
What is it we said it was? Oh, it was a cat feeder. Never mind. Never mind. The cat feeder,
it's like pooping food.
Pooping food.
Pooping cat food.
Yeah, and so methane is one of those things that astronomers will get really excited about when they find it in the atmosphere.
Yeah, but again, and as I know mentioned before, we are only operating off of one data point of life that in the universe, and that's just life as we know it. Whereas, life could evolve under completely different situations that have nothing to do with the need of oxygen and nitrogen, or what, it could be carbon based, or no, we are carbon based. It could be silicone based life. It is, we don't know the possibilities.
Right, but all we can do is start from where we are.
You start with what you know.
And then with instruments like microscopes, or telescopes, you then expand that knowledge, and you're able to understand the universe in a more fundamental way. And you go from there. It's like the study of, like, where you look out into the universe and you see all these things. We have a chair, we have a table, we have a microphone, and all this kind of stuff. Really and truly, these things are only made up of 100 different elements. But if you break that down even further, it's only made up of, really and truly, two different types of quarks and an electron, and that's it.
I guess
three things can make the universe.
I guess you could say that we're all pretty quirky.
And electronic. So, I mean, you can't leave off the electron.
Well, I don't know physics, man.
I mean, yes, we are quirky.
Look, I'm going with quirky because it's, you know what? It's
without electrons, none of this shit would work. We would not have a light. We would not have a microphone.
It's electrifying.
It is like, yes. God, all right. I don't even know where we're going now.
I never answered your question.
Oh yeah. Yeah.
Okay, so I don't know all the discoveries that have been made with telescopes,
and I don't either.
But okay, I do love exoplanets. That's fantastic. Okay, I'm gonna go with something we've already talked about because I think it's Don't boo my joke. How dare you? It was on point. All right.
No.
I just need sunglasses.
No. Katie's right.
No, she's not.
Katie's
I'm a genius in all my.
You are a genius, however.
We are shocking. I like it, Jack. I like it.
However,
Look, my comedy is...
It's highbrow.
It's lowbrow. It's a very lowbrow.
No, you have to think about this. All right, go ahead. Anyway, we've talked about this.
Okay, so we've talked about this. I think one of my number one discovery is proving the church wrong. The sun is at the center of the solar system.
Yes. Okay. Yes.
And just seeing that observational evidence of, hey, look, things can orbit other things and behave like the moon. So therefore, we're not at the center of the solar system. So get off your fucking high horse. So I love that. And then I do also love the discovery that, hey, we're not the only galaxy in the universe. That hey, these fuzzy little clouds that we're seeing, those are other galaxies like our own that are filled with billions of stars that are out there. And
that really is an amazing thing, though.
That is amazing because you're welcome, Adam.
No, it really is an amazing thing because the church put us at the center of the universe.
And I think that's natural.
It's natural.
Totally natural.
And
it's not. That's a human psychological thing.
Yeah, and it's really not a church thing.
However,
it's the church dogmified it, if that's even a word. But and so we're at the center of the universe. Mm-hmm. The Earth is. Everything goes around us.
I'm at the center of the universe.
All right. Well,
my 16-year-old self was anyway.
We're about ready to debunk that really quick. All right. So Galileo, with his telescope, showed that the sun was the center of the universe, and then we found out.
Oh, wait a minute.
The sun is not at the center of the universe. Hey, but thank God the Milky Way is at the center of the universe. And
hold my beer.
Yes. Enter Edwin Hubble, and it's not. And
I mean, that's fun because I just love thinking about, and because of that, you can have a galaxy far, far away. You can have a long time ago in a galaxy far, far away.
Yes. Oh, well done. Yeah. Drink. Everybody take a drink.
And then there is the inspiration and the motivation and just the science that then people go, well, hey, I want to take that idea and learn more about these other galaxies and try to, look at, different what kinds of galaxies are out there, and how do they behave and what forms a galaxy and what, so it just is like, it just really, it opens up, the sun being at the center of the solar system, of course, then open things up. But then when you think about that, our galaxy, our little place in this universe, it isn't unique.
No.
It's common. It's like, we're here, a part of 100 billion other galaxies plus that are out there. It really kind of, it just opens up your world, your universe,
right,
to then explore more and try to figure out, like, how did this happen? How did all this happen? What's going to happen?
Yeah, and discoveries lead to new questions. Mm-hmm. And, all right, so a couple things. Do we need to have a center? No, we don't.
No,
we don't need to have a center.
There doesn't need to be a center.
The whole center of the universe thing, to me, is very humanistic.
Oh,
very
yeah.
Human.
Well, but understandable that we would.
It's completely understandable.
Because it's hard to think of something not being a center. If I tried to think about, like, outside the universe, or my brain melts.
Yeah. And you also asked the question of a black hole. Interestingly enough, there are black holes at the center of pretty much every galaxy that we see. Spiral galaxies, elliptical galaxies, things like that. Irregular galaxies might be
they're irregular.
They might be a little bit different. However, for spiral and elliptical galaxies, they typically have a supermassive black hole at their center. Mm-hmm. There's also even a way of seeing the Big Bang as a black hole. but that's really a kind of a deep dive into that. As far as the question, we're the only blue one, I'm not really quite sure what that means. But if you're referring to the Earth as the blue one,
no.
Yeah, probably not.
I mean, to have liquid water on its surface. I mean,
because
statistically,
there are 100, 200 billion stars
in our
Milky Way alone. And let's say each one of those stars has one planet on average.
Mm-hmm.
We have 9, but on average there's one planet. That means there's 200 billion stars. Let's just be conservative and say 100 billion stars.
Okay.
The chances are that we're the only quote-unquote blue one is remote is pretty much 0. The chances that the percentages that we are the only one that has life on it is pretty much close to 0. You have a better chance of being hit by lightning, winning the lottery 15 times, being hit by lightning again, and winning the lottery 100 times. And that you have better odds of doing that than us being the only blue planet out there. And the only planet that has life. So I'm actually really looking forward to the day that we find life elsewhere.
God.
Because I am immediately going to look to the religions.
They're just going to rationalize it away.
But they can't.
They'll figure
there
out a way.
There are some cannot.
No, the mental gymnastics they take.
No, the Baptist cannot. We are all there is. We are life.
They'll change the rules.
God made us. We are in God's image. And so if you
I'll change it right now. God made them too.
If you find life on Mars, it better goddamn look like us. Because God made it in their image.
God's a shapeshifter.
His image.
Oh,
his
right,
image.
yeah, because, vaginas.
Penises. Because it's all about penises.
Yeah.
Vaginas are the lack of penis.
Yeah.
So.
Vaginas, but lack of penis.
It's a lack of penis.
Meanwhile, the penises started out as vaginas.
That is true. That is true. All men started as women. And then the vagina just dropped out. Then became an outie instead of an innie. Oh my God. Had too much to drink. All right, I gotta say,
bye,
Jack, have fun with Sunday sushi.
Have fun with after that note.
Cheers.
Oh my God. All right, let's ring this in. We'll rein it in now.
I think you have to ring it in.
You're the host.
Yeah, but I've had more drinks than you have.
Your drinks were just taller.
What?
Your drinks were just taller.
Oh no, they actually have more alcohol in them.
What?
Yeah, because I have more. I have more volume than you have with yours.
Rude. Anyway. All right.
Oh, your drink would overflow.
Last bit of drink there, because apparently there's something happening outside.
Yeah, who knows? Yeah, telescopes have really. The only way that we can really and truly explore the universe, except for these very isolated spots on Venus, the moon.
I'm actually not feeling that drunk. I'm just having a good time.
I'm actually kind of feeling it.
I'll have another drink after this, but anyway.
Except for Venus, the moon, and Mars, the only way in which we can
explore the universe.
Explore and experience the universe is through light.
Yeah.
And we need these light buckets, as you called it.
Light buckets. Whether they are here on Earth or orbiting the Earth or going through space, we need the light buckets.
Beelzebub's light buckets.
Beelzebub's light buckets. But we only sell Toyotas.
We only sell Toyotas.
On that note, everybody, I would like to say, just go outside at night. Look up. Use your built-in telescopes called your eyeballs. and look at the stars and see what's out there, or go to a star party and hang out with some amateur astronomers, and let them get all nerdy and tell you what you're looking at out there.
Yeah, let them have their moment. They're very excited. Like I said, they really are.
And some of these amateur astronomers at star parties and part of these astronomy clubs, like, they invest a lot of money into these telescopes, or they build their own telescopes.
All of them do. All of them do. That have telescopes, yeah.
It's quality shit. Or go to your local planetarium. You know, if you're in, where's Jack in Iowa?
Yes, Iowa. Nebraska. He's in Nebraska.
He's in Nebraska.
But he's from Iowa.
The Rolling Hills Planetarium is. I hope that's right, Jack. I'm sorry. I know you're not here anymore, but look at the night sky. Don't fall into existential dread like my anxiety-ridden sister looking at the night sky.
Okay. Here's the thing. Like I said before, you don't feel small. Don't feel that the universe is so big. First of all, just like Liz said, first of all, you're part of it. But second of all, you're able to understand it.
You evolved opposable thumbs.
You personally did not evolve personal thumbs.
No, over billions of
years. Ancestors did, which means you have opposable thumbs. However, you're able to fundamentally understand the universe. You can go out into your backyard or to a star party or to a park
or planetarium,
wherever, but you can look up and you can see the stars. You can understand what they are, where they are, and that they are very far away from us, and they are emitting their own light, which allows you to, the fact that that light, say Betelgeuse, for example. Is, or however you want to pronounce it, is over 400 light years away.
It took 400 years for that light to reach your eyeball.
Yeah. So, but not only did it take
Maybe it's 600?
Okay, we'll say 600. That's even better. The light that left Betelgeuse left that star before North America was discovered by Christopher Columbus.
Oh, fuck.
May he rot in hell. Christopher Columbus discovering America, even though the Vikings discovered, 1,000 years earlier. Discovered, quote unquote.
Happened upon it.
Yeah, but it's really people from Asia that discovered America. Anyway. So that light left that star and traveled through space, did not get intercepted by an alien species, another planet, another nebula, moon, or anything.
Made it to your eyeball.
Into your eyes and allows you to see it. Basically connecting you to that star. Everything that you see, you're connected to. You are connected to the universe. You are part of the universe. You are not small. You are
a giant.
You are substantial. You are a giant. You understand you can perceive the universe. And we're not small. And we're not small at all. We might be only at most 6 feet tall, but with our brains.
Most 6 feet tall?
Okay, there's people that are fucking 8 feet tall. But on average, 38 miles an hour and somewhere between 5 and 6 feet
I know
tall.
we're trying to close this out, but my mom just said, I think of Michael Keaton, and I really need her to expand upon why she thinks of Michael Keaton and how that relates to not feeling small in the universe.
Did I really fuck that up? That she thought of Michael Keaton?
No, I don't know. She says, I think of Michael Keaton, and I don't know why. She thinks of I think of Michael Keaton, and I immediately think of Batman.
All right, well, while we get this answer, you either put it in chat or text us.
I like that. Yes. Oh, Beetlejuice. Yes, Beetlejuice. Okay.
Yes.
I see that now.
All right, that's obvious.
That's one of my favorite. I love Beetlejuice. Anyway.
But we are part of the universe. We can understand the universe.
Like ants. Ants can't understand they can make their own air conditioning, but
No.
they can't understand the universe.
Not in the way that we understand the universe, but we're all part
of the universe.
Part of the universe. And what's amazing is we can invent microscopes to show us, things that our eyes can't see, bacterium and...
Microscopes are things our eyes can't see, but telescopes show us things our eyes can't see also.
Yeah, one just goes very small, one goes very big.
It's like universal glasses for a telescope.
Telescopes and microscopes are really the same thing. It's just the way that you orient them.
Yeah.
And the universe is an amazing place, and we've been able to invent these incredible tools, telescopes, microscopes, colliders.
And to think we just started with making rocks sharp.
We really have. We've come a long way. We've come a long way.
On that note, I think it's a good time to sign off.
Yeah, and go get a pizza.
This has been fun. I love telescopes, and I love what we can see with telescopes.
I want to go look through one.
What we've learned with telescopes. Well, it's daylight out right now, so it's not going to work too well.
We can look at the sun.
No, don't.
Never look at the sun. Don't look at the sun.
Unless you have a filter on your telescope, like a hydrogen alpha or whatever they use.
Or the Mylar filters.
Yeah, don't. You can look at we didn't even talk about looking at the sun through a telescope. God damn it.
All right, so I do need to say this. The service announcement.
Oh, okay. PSA. The more you know.
Never look at the sun through a telescope. You're instantly blinded. Second of all, Pop-Tarts, the little things that come in Pop-Tarts are made of Mylar. So you might hear that you can look at the sun through a Mylar filter. The little plastic metal things that Pop-Tarts come in is made out of Mylar.
Oh.
Do not look at the sun through Pop-Tart containers.
Would have never thought of that.
Yeah, but stupid people have.
Oh,
and
so
don't do that. Also, if the moon is full and you're looking at the moon through a telescope, please use a lunar filter. Yeah. It will actually induce temporary blindness in your eye.
Yeah.
And so...
The sun's bright, people.
The sun's bright. The full moon is bright. And all that light coming through a telescope. Remember, these are light buckets, so they're collecting light, and they are magnifying it and intensifying it. And so please never, ever, ever, ever look at the sun through a telescope, and be careful when you look at the full moon.
Without the proper filtering equipment.
Yes, and to be honest, if you do not know the person showing you, then you need to, actually question them. What kind of filter is it?
Yeah.
Is it safe? How about you look through it first? And
also, you can also ask them what they're using, and then you can Google it and then see if that's.
You have a pocket computer called a cell phone. So.
Oh, my mom didn't know that about the moon. Yep. Yeah, it's just reflected sunlight, and when it's full, it reflects a lot of sunlight. So
a lot of sunlight.
It can actually. In fact, the best time to look at the moon through a telescope is when it is in like a crescent phase,
or even a quarter phase.
Even a quarter phase. And that's because A, it's not going to blind you, and B, because the Terminator line, which is the line between the night side and the day side on the moon, essentially, it casts shadows on the mountains and the craters, and so you get this really beautiful textural relief.
Yes, and the moon actually looks three-dimensional. Yeah, it does not look flat.
It's amazing. It's the best time to look at the moon.
Full moon, the moon looks very flat. You're basically looking at it at noon, locally on the moon, and there's no shadows and craters, but
it's too bright, not that great.
Crescent, you get not only these beautiful rich shadows within craters and mountains and stuff like that. You also can possibly get earthshine on it.
Oh. Yeah.
So reflected light from the sun, light from the earth, illuminating the night side of the moon. So,
in fact, if you go outside and look at the moon at night, and it's in a crescent phase, but you can still see like the rim of like the dark portion of the moon. That is illuminated.
Earthshine.
That's Earthshine. It's illuminated from reflected sunlight off the Earth, essentially, which is cool. All right, we got to wrap this up. We got to go.
All right, everybody, again, stay safe, stay healthy, go out, look at night sky, wear your mask, because there are a lot of dumb people in the world. And we will see you in 2 weeks. So cheers, everybody.
Cheers, have fun, and follow us on all things. Did you say that?
No, but you did. So follow us on all the things. Instagram, Twitter, and wherever you get your podcast.
Bye.
Bye, everybody.
We'll see you.